8.1, make a little change here. 8.1b notes. We're going to look at the special cases of systems of equations. And so there's three types of solutions you're going to see with a system of equations. The first type, the regular type, the type we expect the most often. One solution is when the two lines intersect or cross each other. However, when you have infinitely many or many solutions, what happens is that the lines are coincident, and that means they coincide. They are basically on top of each other. It's the same line twice. It's the same line twice. That's no good. But a no solution case happens when you have the same slope, meaning that the lines are parallel and they have no intersection. So in other words, we're asking a question that doesn't make any sense. We're asking where the lines cross and they don't. So let's look at an example of one solution. This is a review of what we did last week. We have two lines. They're both nicely solved for y. We'll do one in red and we'll do the other one in blue. One in red is going to start with a y-intercept of -3. So from the origin, go down 1, 2, 3, put a dot. The slope is 2 or 2 over 1. 2 over 1 means go up 2 and over 1. Up 2 and over 1. Continue that. And the other line, we'll put in blue, starts at 2, 1, 2, and has a slope of -1/2. So -1/2 slope is going to go down 1 and over 2, down 1 and over 2, or up 1 and left, up and left. Did you see the place where the two lines crossed? Or intersected is right here, and that point is over 2 and up 1. Let's do another example of a one solution. This time the lines are not solved for y. So if we take them individually, first 2x plus y equals 1. If we take away 2x from both sides, then we get y equals -2x plus 1. And now here's the second line, x plus 2y equals -4, and we'll just take away x as a first step, making a 0 there. And so it's -x minus 4, but then we'll divide by 2. Everything by 2. So y is -1/2 x minus 2. Okay, so again, we'll do one in red, and we'll do the other line in blue. The red line is going to start at +1, up 1 from the origin, and have a slope of -2 or -2 over 1. Kids, I am recording right now. Shush. Okay, so from this point, I'm going to go down 2 and over 1, down 2 and over 1, down 2 and over 1, or up 2 and left 1. Here's my first line. Second line, we'll do it in blue. Has a slope of -1/2, but it starts at -2. So starting down 2 from the origin, we'll go with a negative slope of, oops, sorry about that, down 1 and over 2, down 1 and over 2. Did you see the point of intersection? So it is not true that one line must be positively sloped and one must be negatively sloped. They can both be negatively sloped. That point is over 2 and down 3. Now let's look at an example of no solution. So what's going to happen here? These red lines are not from me. We're just going to have to deal with them. So if we take the first line, x minus y is 2. We'll take away x. Negative y is negative x plus 2. And then divide by negative 1. Y equals x minus 2. There's the first line. The second line starts x minus y equals negative 1. Take away x. Negative y is negative x minus 1. And divide by negative 1. They have the same solution steps. This is a big giant clue that they are parallel. And then it's plus 1. So the first line we'll do in red. This one starts at negative 2 and has a slope of positive 1. So it goes up 1 and over 1. Up 1 and over 1. Continues to do that. Or down and left and down and left. So there's our first line. And our second line starts at positive 1 and with that same slope. So it's because the lines have the same slope that they are not ever going to cross each other. Since they don't cross, they don't have a point of intersection, and therefore we would say as an answer, no solution. Okay, finally, an example with infinitely many solutions. So 3x minus 9y is 18. If we divide, well, let's do this. Let's take away 3x from both sides. And so negative 9y equals negative 3x plus 18. And then we'll just divide everything by negative 9. So y equals 1/3 x minus 2. There's our first line. Our second line, x minus 3y is 6. We'll take away x from both sides of the equal sign. Negative 3y equals negative x plus 6. And divide by negative 3. And so you can see we get exactly the same equation. That one is the same as that one. So it's almost as if the red line, which has a slope of 1/3, goes through negative 2, and the blue line occupy the same locations at the same time. That's why we say there are infinitely many solutions. Or sometimes people just say many solutions. Now, for the next part here, example number 5, let's see if we can figure out what's going on here. We'll take the first equation, 2x plus y equals negative 7, and we'll solve for y. So y is negative 2x minus 7. We'll go start down 7. I'm going to use red for this one. Down 1, 2, 3, 4, 5, 6, 7. That's our initial value. We can't really go down and over, so we'll go up and left. Up 2 and left 1, up 2 and left 1. And that gives us our first line. And let's take our second line and take away 5x from both sides. So 7y is negative 5x plus 7. Now we'll divide by 7. Y equals negative 5/7 x plus 1. So we're going to start at 1. We'll do this one in blue. Start at positive 1, and our slope is negative, so it falls from left to right, or rises up and goes left 5 to 7. So let's go up 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6, 7. There it is, right there is our point of intersection. And we'll get the coordinates off of that. This point right here is left 1, 2, 3, 4, 5, 6, 7. So it's left 7 and up 1, 2, 3, 4, 5, 6. Negative 7, 6. Now this time we're going to do more than just say that's the answer. We're going to prove that that's the answer. So here's how you do that. You check a point as a solution by doing two things. You plug in the given point. Okay, now this is the given point we're talking about. We're going to plug that point into both equations. And the point must satisfy. There's that word again from our notes last time. To satisfy means that you have to be able to plug it in and it gives you a true statement. So we're going to satisfy both equations, our solution. Now, in this case, we're going to try the point 4, 3 on a different system of equations, and we'll see if it works or not. So for the first equation, it says y, we would put in 3, and is that equal to 3 times x? So we'll put in 4 minus 11. Is that true? Is 3 equal to 12 minus 11, which is 1? No. See, I don't even need to check, cut. I don't even need to check the other equation. If it doesn't work for one equation, it's not a system of equations. So I'm going to go ahead and say false right now. That is not a solution to that system. Well, let's look at the other one. The other one, believe it or not, x equals 4 is a line, and it straight up says x is 4. Sure, the point says x is 4, so it works for this one right away. The second line says y, which is 3, is equal to x, which is 4, plus 1. Is that true? Does 3 equal 5? No, false. So this point 4, 3 is not a solution to the first set of equations or the second set of equations. So what does that mean? It means you have the ability to check your answers. You will always have the ability to check your answers to a system of equations. And this is the end of our notes for 8.1b.